So earlier on today, I posted this question and asked that we should provide a solution to this question, but only a few people attempted it. So I say, all right, let me solve it so that we can all flow together. Is that clear? Now the question is asking us to find the dimension of x, given that x is force times distance divided by velocity multiplied by time. We have to find the dimension. Now for a question of this nature, let's solve it together. So first thing first, we have x is force. Now if you remember, what is the formula for force? Force is equals to mass times acceleration. And what is the dimension for this m is represented by capital M if you are writing it using dimensional quantities. While acceleration, remember acceleration is change in velocity all over what? Time. So the dimension for acceleration is what? L t per t square. That is the formula for, that is the dimension for force. So now because this is the same thing as force, we can write this, our force, as m L per t square, then times distance. Remember, when we are talking about distance, we are just talking about length. Is that clear? So since we are talking about length, we can write distance as L, length. Is that clear? So all over. Now we have velocity. What is the dimension for velocity? Now remember, velocity is distance all over time. Now distance is length, and t is represented by capital T. So I can write this thing as L. If I bring this t up, it will be t to the power of minus 1. That is t inverse. So it's the same thing as, this is the dimension for velocity. So instead of writing velocity, I'll write L t to the power of minus 1. Exactly. Time is time again. So time is represented by capital T, just like the way I did it here. So now this is what I have as dimension. So now we have to multiply common terms together and see what we are going to get as our answer. So we have that. Now mlt to the power of minus 2 times L. And remember this, we have L here, we have L. By the time it multiply, we are going to have L squared, because L times L will give us L squared. So this becomes M, this L now will be L squared because of this L. If they join together, they become 2. So times t to the power of minus 2 all over. Now for this one, we have t to the power of minus 1 times t. Lt to the power of minus 1 times t. So these two now, they are going to multiply each other. But according to the laws of indices, if you have the same thing raised to the power of, if you have something raised to the power of the same base, so what you do is you add the powers. Remember, this is like the power of 1. So we have like 1 plus 1. So you are going to add the powers, okay? You are adding these powers together. So if I have minus 1 plus 1 is going to give me what? 0. So that means t now is going to become 0. And anything raised to the power of 0 is the same thing as 1. So that means this t and this t will go. So what will remain here is only this L. Hope you understand? So I'll write only L here, because the t times t is going to give me t raised to the power of 0, and t raised to the power of 0 is the same thing as 1, so I'm only left with L here. So from here, I'm going to also bring this L up here. By the time I bring this L up, it's going to be, this is going to be m L square t to the power of minus 2 times L to the power of minus 1. Because I brought this L up now to be to the power of minus 1. So now I have m L square t minus square L minus 1. So I'm going to multiply this L by this L, just like I taught you before, again using the laws of indices, because they are the same thing. You are going to add the powers. Now here we have 2 plus minus 1. So we have 2 is the same thing, 2 like minus 1. And this is going to give us 1. So that means my L is going to be 1. So the final answer for this will now be M. So the L now is to remain 1. So it will become L. So I don't need to write 1 since it's just 1. We don't need to write it. Then T minus square. So this is the dimension of x that we are asked to find.